The graphs of functions f of x and g of x are shown below. We want to sketch the graph of the inverse of g on the axes below. I'm going to do it on the same axes that g's on because it's just easier for me to do that when I'm doing a video like this. We know that it's going to be the reflection in the line y equals x. So if we look at this point to start with, that would reflect to here. This point here will reflect to here, and so that part is going to be like so. So this point here would reflect to here. This point down here would reflect to here, and so that reflection is going to be a straight line section like so. Okay, I'm just going to clear this because I'm going to need this graph again, I think. So we want to state the value of g times the inverse function of f of 0. So let's go back to the graph. So what would the inverse of this one look like? So here's y equals x. So we're going to have the reflection of that section is going to look something like that. And so we can see that that's going to be -1. So that is f to the -1 of 0 is equal to -1. And then we want g of -1, which appears to be 3. Okay. So we now want to determine the set of values of x such that f of g of x is defined. So it's probably going to be some sort of problem here if we just use the whole thing. So we're doing g first, and then we're going to go ahead and do f. Now if we look at f, it's okay for values between -4 and 2. And that means that the output from g is going to need to be in that range, because that's then going to go into f. So it looks like we can't have any of these values because the output there would be 3. So it looks like it's only between 1 and 3 with the 1 not included. So it looks like we're going to have x is a real, x is more than 1, less than or equal to 3. Okay, and finally, oh no, it's not finally, there's a part E as well. Okay, sketch the graph of y equals f of negative mod x on the axes below. So I'm going to do it up here. So we know that if we have f of mod x, then we take what's to the right of the y-axis and reflect it over onto the left, ignoring what's on the left. If it's the negative here, we do the opposite of that. In other words, we're going to keep this stuff that's on the left, and then it's going to reflect across. So it's going to go like that, and it will go up to here. So it's going to look like that. And let's go and see what's the last part of this question. Okay, the first bit's just a statement about a spare grid. The equation mod x plus 1 is equal to k take away mod x plus a has an infinite number of solutions, with the solution set being -3 to -1. Determine the values of the constants a and k. Okay, so I might use this grid just up here to help me with my graph. Let's look at mod x plus 1. That's going to bounce from -1, and it's going to look like this. Now we have k take away mod x plus a. It's got the same solutions from -3 to -1. In other words, that one's going to track along here. So that means it's probably going to, looking at the form of it, it's going to bounce down at this point just here. Now the k is clearly going to be a vertical translation. So it suggests to me that k is equal to 2. The bounce is at -3, suggesting that a is equal to 3, because then we have x plus 3 in there, and that would change when x is -3.